together. So we know already from the binomial expansion that if we were to expand this out, we know this part here, n equals 4, and so we can write out the expansion using nc0 x minus 2y plus nc1 x minus 2y. I'm going to put the powers in a second. Plus, instead of writing n, let's write 4. 4c1 and 4c0. And then we've got 4c2 x minus 2y plus 4c3 x minus 2y. And finally, 4c4 x minus 2y. Now, over here I've got a naught. So where's that naught going to go? On the x or the minus 2y? Gulsum, where does this naught go? Sorry? So one of these x and minus 2y is going to have a power of naught. Which one? Excellent. And therefore the x will be which power? Charlie? 4. Okay. And then we have 1 over here. So this must be a power 1. And the x will be what power, Declan? 3. Excellent. Then we've got a 2 here. Alana, where does that 2 go? Remember the r goes on here, this one here. So which one has the power 2, x or the minus 2y? Minus 2y. Okay, and then so this one here, Rohan would be what? This one here. Let me just put that on. This x would have to have what power? Remember the powers add up to 4. So if that's 2, what would this be? Can you guys be looking up, because when I do ask you a question, you might get a bit lost. This is not going anywhere. Okay, so if this is a 2, what would this be? 2 as well. Right, because we can see the powers add up to 4. Yeah, so 4 plus the 0 is 4. 3 plus the 1 gives us 4. 2 plus the 2 gives us the 4. We can also see that when you've got r here at the bottom, maybe that's a bit dark. So if you've got r here, it goes on the second term. So there's your r, it goes on the second term. There's your r, goes on your second term. There's your r. Okay. So Francesca, that 3 will go where? This one here, this 3 goes where? Which power? Excellent. And then therefore, this would be Naima. What power would the x be? 1. Excellent. So 3 plus 1 gives us the 4. And then we've got this 4 here. Okay, Whitney, where's this 4 going to go? Okay. This 4 here, this 4, one of the x and minus 2 are one of them is going to have this power of 4.
Which power of 4?
It's going to have a power of 4. Where is it going to go? Look what happened to the top one. The 0 went to the second term, 1 goes second term, minus 2y, so that becomes 4. If that's a 4, what's the x going to be? What power? Remember they add up to 4, so 4 plus 0 is 4, 3 plus 1 is 4, 0, exactly. Okay, and then we can tidy that up. We know 4c0 is going to be what? In Pascal's triangle, the first number, Yasmin, is always what? 1. Okay, so 1 times x to the 4 minus 2y to the power of 0, Anjum, is what? Anything to the power of 0 is what? 1, good. Then we've got 4c1, Anwar, sorry, Lukman, what does that give us? 4c1? 4. Okay, can you please be like, just make a note of that. The first term, remember Pascal's triangle, 1, 1, 1, 2, 1, 1, 3, 3, 1. The first number is always going to be a 1, and the second number is always going to be n. So we'll get a 4x cubed minus 2y. Okay, and then we've got a 4c2 How do you work out what 4C2 is?
6.
Charlie? Okay, how do you get that? So 4C2, let's just do that here on the side. How many fractions do we need? 2. Okay, look up please. So what goes here at the bottom, Fabian? 2 and 1. What goes there at the top, Simke? At the top. So we're working out 4C2. I've got 2 and 1.
4 and 3.
4 and 3. Can we simplify this before we multiply it out? 4 divided by 2? 2. So 2 times the 3 gives us a 6. So we've got 1, 4, 6. Then you've got x squared minus 2y all squared. And then by symmetry, we can just see the 4, 3, 3 will give us what? If it's 1, 4, 6, 4. Good. Okay, and you've got an x minus 2y to the power 3 plus, and then what's this one going to be? The 4C4, Charlie? Just the 1. Okay, and we'll end up with minus 2y to the power of 4. And we can tidy that up further. So we've got x to the power of 4. Minus 2 times 4 is minus 8x squared y. 2 squared, minus 2 squared will give us what? Beth. The minus 2 squared will give us. So, where are we? Yeah. Yeah, so 4 times the minus 2. So here, if I highlight the coefficients, just give me a second. Okay, so what should be cubed? So we've got 4 times x squared times minus 2 times minus y. Oh, sorry, is that a cubed? Okay, thank you. Okay, thank you. Yeah? Alright, and then you've got 6x squared minus 2y. Kunle's just walked in. Shami, what do we get for that? Over here, what coefficient, when you multiply this out, what's the coefficient going to be? So you've got 6 times the minus 2 squared. 20, 24, yeah. And would it be a plus or a minus 24? Why is it a plus, Gulsum? Yeah, good. All right, and in that case, what coefficient would I get for my next term? 4x minus 2y cubed. Sumaya? This one here. So I've got minus 2 cubed. Sorry? Minus, good. And what number would I get? So I've got a 2 cubed times a 4. Good. Why is it a 32? Excellent. So you've got a minus 32xy cubed, and then 2 to the power 4. How do you do that? 2 to the power, that's a big number, 2 to the power 4. Who's got a shortcut for doing 2 to the power 4? Jude. 2 to the power 4, do you just do 2 squared, squared, squared? Yeah, you could, yeah. If you get anything to the power 4, I mean, it could be 3 to the power 4, 5 to the power 4. Remember, that is just 2 squared, squared. So you can just do 2 squared 4, 4 squared 16. And so that gives us, would it be a positive or negative 16? Positive 16y. Is that correct? There's a mistake there somewhere. What should be to the power 4? Y. Okay. Sorry? Beg your pardon? Oh, I see, yeah, because the powers always add up to the 4, isn't it, yeah? So you've got 3, 1, 2, 2, 1, 3, and then a 4. Is that okay? So you should always get a total of 4. Alright, so that's what we did last lesson. What I want to do is basically just extend the idea a little bit, like so. So if I just bring this over, I'm going to ask you to copy this down in a second. But say we didn't want to do the whole expansion. We just wanted to work out the x squared term in this. That's all we want to do. Just work out the x squared term. In that case, what we can do is use our standard formula. We know that the x squared term is going to come by doing a minus 2x squared. And we'll have 5c2. And therefore the 3 will have to be a power 3. We can then work out what we'll get. And we should get 1080x squared. So could you copy that down, please? And actually, while you're doing this, what I'll do is I'll take a picture and just add a side note to it. Why don't I do that? So this is part of the note, so you've got that in. Okay, and let me just put a side note in to say that the formula we're using, okay, is NCR. So if I've got A plus B to the power of N, I've got NCR times A times B, but B will always be to the power of R, and A will therefore be N minus R. And that gives me any term in the expansion. Okay, so remember, the powers add up to N. Okay, so N equals N minus R plus R, which is N. And so that's the first thing. And the second thing to note is that this small part here, R, is always going to go on the B as a power. It'll always go on the second term. Okay, and then that allows us to work out any term in the expansion. And I showed you the shortcuts yesterday, yeah, with the fraction part, and you can cancel down. And the symmetry. So 10C8 is the same as what? Anyone? 10C8 is the same as 10C2 because of symmetry. Okay, 50C48 is the same as what? 50C2. 50C45 angium is the same as what? 50C5, right? So straightforward. Is that okay? Have I lost anyone? 50C47 Simgay is the what? Same as what? 50C47. 50C47. Excellent. Alright, so if we had to work that out, we can then do 50C3, write down 3 fractions, 3 to 1, 50, 49, 48. Simplify those numbers down, then multiply out. And that's what you do. Alright, does that make sense? Alright, let's have a go at doing one. So I'm going to reset this. Can you work out the x4 expansion in this? Hands up when you're done. Okay, super. Okay, this is what we get. Hands up if you got 80. Okay, excellent. Why is it what? Okay. Alright, what I'll do is I'll put that in the notes. Again, I'll put a screenshot in. Seems like, generally speaking, everyone on each table. Hands up if you've done that. You've got the 80. Seems like on that table. I think just this table here. You guys still working on it? Okay. Alright, do you want to copy that down if you haven't got it? And I'll just finish off with the last concept of binomials, and then I'll just let you get on with the sheet that I gave you, the level 1, level 2 questions. But before that we do that, let's just cover the last concept. And then if anybody wants me to go over anything, I'll do it. The test is 20 minutes, so we'll start in about 10-15 minutes. Yeah, we'll start. It's only like 15 marks, so 20 minutes should be quite sufficient. Right, let's have a go at this. Let's have a go at this question here. Right, you've got to work out the first 4 terms in expansion. Substitute in x equals 0.1 and find an approximation. I think, yeah, these are good questions. And then compare this approximate value with the answer you get on the calculator. Okay, now obviously the C1 actual exam is a non-calculator one. And I don't think there has been an approximation question that's actually come up in the papers, but it is on the syllabus, so it is worth knowing how it works, being able to do a couple of questions on them. Okay, so I'll give you about 5 minutes if you have a go at that, and then we can take it from there. We obviously started by going over an expansion. So if we did this, we should get 1 plus 60x plus 174x squared plus 32480x cubed. So that gives us the first 4 terms of the expansion. If we then, can anyone just look up for a second? If we then put in 0.01, what's 0.01 times 2? Add 2, so you get 1.02 to the power of 30 approximately equals, now if we just put in these values, so 60 times 60 times 0.01, 60 times 0.01 plus 1740 times 0.01 squared plus 32480 times 0.01 cubed, and that square sign should just go outside. Okay, And if we work that on the calculator, we should get. Anyone want to do that? What do you get? You can see Jude is working away. What do we get? Anyone got an answer? So if you put 0.01 in place of x for the first three terms, what do you get when you expand it out? 1.8. Let's do it to about 5 decimal places. 1.8. 0648. Excellent. Now if we were to use a calculator and you did 1.02 to the power of 30, what do you get? 1.81136. Okay, so therefore our approximation is correct to 2 decimal places. Yeah, to 2 decimal places, which is quite good. Approximation is correct to 2 decimal places. That's quite amazing, because look, there's 30 terms in the expansion. We only use the first 4, and that's correct to 2 decimal places. We could work out the difference and divide it by the original and times by 100 to work out a percentage error if you wanted, or percentage difference. But that is pretty good. It's just within 2 decimal places just by using the first 4 terms of the expansion.